Skills assessment using ASA 5506 Form A. Topology. Cancel. Two routers with iOS 15.0 in my case. This is R3. The ASA two switches, Cisco IO L2, S1, and S2. Generic Ethernet switch here, S3. So Linux PC here, down here. This will be PCA. Okay. PCA. Two Windows PCs. Another Windows PC here. PCB and PCC. PCB and PCC. Instead of using serial 000 on R3, I will use serial 30. So connections serial 30 to connect serial 31. Okay. Instead of using serial 001, I will use serial 31. And here, instead of gigabit 01, I will use gigabit 10. Gigabit 10 and connect any port on the switch. And from any another port on the switch to PCC. Gigabit 000 and instead of using gigabit 11, I will use gigabit 01 on ASA. From gigabit 00 to gigabit 01. Instead of gigabit 12, I will use gigabit 02 on ASA. And then connect 24 on S2. But I will use another port on S2. Gigabit 02 on ASA to, instead of using gigabit fast Ethernet 24 on switch S2, I will use the last port, in this case Ethernet 33. Okay, Instead gigabit 1.2 on ASA, I'm using gigabit 0.2. Instead of use fast Ethernet 24, I will use Ethernet 3.3. Instead of fast Ethernet 0.1 and 0.2, I will use Ethernet 0.1 and 0.2. The connection between switches, Ethernet 0.1 and 0.2. Connection to PCA on fast Ethernet 6 from S1 fast Ethernet 6, but in this case Ethernet 1.2. And from S2 to PCB fast Ethernet 18. In this case 3.1 to Ethernet on PCB. Show height interface. Start R1. Okay, first of all, set the hostname. Configure terminal hostname R1. Now IP domain lookup and configure gigabit 000 225 subnet mask 29 interface gigabit 00 IP address 209.165 200 225 255 255 248. Enter. No shutdown. Now serial 31233. Interface serial 31. Remember, instead of using serial 001, I'm using serial 31. IP address 209.165 200 233 subnet mask 252. Then no shutdown. Create a static route to reach this network. Exit IP route 192.168.10.0. Use the NetSwap IP address 226. 209.165.200.226. Enter. And create another static route to reach this another network. IP route 172.30.30. Subnet mask 255.255.255. Use the NetSwap IP address 234. 209.165.200.234. Now, this router R1 should be an NTP server. This NTP server can be implemented on GNS3, but GNS3 will go crazy. And I don't recommend to use NTP server on GNS3, so I will do it on a notepad. Okay, but R1 should be configured as the NTP server with authentication. So use a notepad. This is R1, and you are on global configuration mode. And here, set the NTP authentication dash key number 1. Use MD5 NTP password will be this is the password. The authentication key will be the number 1, and the MD5 password is NTP password case sensitive. Okay, the NTP trusted key will be the number 1, and NTP authenticate to enable authentication, and set the stratum for the server NTP master 3, and enable the NTP server. Okay, all these configurations for the NTP server on R1. Now start R3. Okay, set the hostname, configure terminal hostname R3. Now IP domain lookup, configure gigabit 10. Remember, I'm using gigabit 10 on R3 instead of using gigabit 01. Interface gigabit 10, IP address 172.30.30.31. Subnet mask not shut down. And serial 30, remember I'm using serial 30 instead of using serial 000 on R3. IP address 234. Interface serial 30. IP address 209.165.200.234, subnet mask 30.252. Now shut down. And now create a static default route to reach another networks and internet. Exit IP route, static default route, and use the NetHub IP address 233. 209.165.200.233. This is enough for R3. Now configure S1. Start the device. Now set the hostname. Configure terminal. Hostname S1. No IP domain. Lookup. And set the root primary for VLAN 1. Spanning tree VLAN 1 root primary. Now shut down all unused interfaces. Okay, exit. And to do this, first of all, list all the interfaces. Show IP interface brief. These are all my physical interfaces. But I have in use Ethernet 1.2, Ethernet 0.1, and Ethernet 0.2. Configure terminal interface range, Ethernet 0.0, comma, Ethernet 0.1 and 0.2 are in use. So Ethernet 0.3, Ethernet 0.3, comma, Ethernet 1.1, Ethernet 1.2 in use. This, okay, Ethernet 1.2 in use. Ethernet 1.3, comma, from 2.0 to 2.3, from 2.0 to 2.3, 2.0 to 2.3, from Ethernet 3.0 to 3.3, Ethernet 3.0 to 3.3. Enter. And shut down these interfaces. Shut down. Now start S2. Configure terminal. Set the host name S2. No IP domain lookup. And set the root secondary for VLAN 1. Spanning tree root secondary. Spanning tree VLAN 1 root secondary. This is enough for S2. Now start this virtual machine PCC. But before to start this virtual machine, go to VirtualBox because is this Windows 10.2, this virtual machine, and verify this virtual machine is configured on network settings with generic driver, UDP tunnel, cable connected. The same configuration with the other virtual machines used in this topology. Generic driver, UDP tunnel, cable connected. The Linux virtual machine and the Linux virtual machine configured. Generic driver, UDP tunnel, cable connected. Okay. Verify that before to start virtual machines. So start PCC. Configure the interface on PCC should be number 3. The Ethernet interface 172.30.3.3 subnet mask 24 default gateway 172.30.3.1. Okay. Very nice. This is the configuration. Verify network connectivity. In the interest of time, your instructor has pre-configured basic settings on R1, R3, and configured the static IP address information for the PC host in the topology. You will verify that PCC can ping the gigabit 01 interface on R3. Ping from PCC to gigabit, in my case 10 on R3. Ping the gigabit interface on R3 from PCC. Basically, it's the default gateway. Ping to the default gateway. 30.3.1. Success. Ping interface serial 001, in my case serial 31 on R1 from R3. From R3, ping to this interface serial 31 to 33. Go to R3 and ping 209, 165, 200, 233. Success. Configure secure router administrative access. You will secure administrative access on R3. Okay, all configurations only on R3. Set minimum password length to 10 characters. Okay, go to R3. Configure terminal. Security passwords. Min length 10. Enter. Oh, sorry. TH. Enter. Assign and encrypt privileged access password. The password is Cisco12345 in encryption type 9 script. The exact password, so it's the enable algorithm type script type 9 script and the secret Cisco12345 case sensitive. Enter. This command is not supported by my iOS 15.0. This command is supported by iOS 15.4 and later. But this is the correct answer. By the way, I will use common encryption using the enable secret Cisco 12345. Enable secret Cisco 12345. But remember, this is the correct answer. Add a user in the local database or administrator access. Now, create a username. The username is admin01 case sensitive. Admin01. Privilege level 15. Privilege 15. Encryption type 9 script. Algorithm type script. And the password is admin01 pass. Secret admin01 pass case sensitive. Username admin01 privilege 15. Algorithm type script. Secret admin01 pass. This is the correct answer, but again, it's not supported by iOS 15.0. So I will use a common encryption using this command. Username admin01 privilege 15 secret admin01 pass. But remember, this is the correct answer. Configure a message of the day banner. Banner message of the day. When authorized access is prohibited. Enter. Disable HTTP server services. No IP HTTP server. Configure SSH. Domain name CCNA security.com. Domain name CCNA security.com or CCNA security.com. Any. Don't forget IP domain name CCNA security.com. The RSA keys 1024 bits crypto key generate RSA general keys modulus 1024 bits. Enter. Version 2 for SSH. IP SSH version 2. Timeout 90 seconds. IP SSH. Timeout 90 seconds. Authentication retries 2. IP SSH authentication retries 2. And use dash. IP SSH authentication dash retries 2. Configure VTY lines to allow SSH access. Allow only SSH access. Line VTY 0 to 15. Transport input SSH. Only SSH. Configure AAA authentication and authorization settings. Enable AAA. Exit. AAA. New model. Use local database as default settings. AAA. Authentication. For login default, use the local database. But don't forget it's authentication and authorization, so also configure authorization. Authorization for exec. The default will be the local database. Enter. Now configure the NTP client in this case, because R3 will be the NTP client of R1, because suppose R1 is the server. Authentication key, NTP password, case sensitive. NTP authentication key. Use the key number 1. Use MD5 and use this password, case sensitive NTP password. Enter. Enable authentication NTP authenticate. And this is the server 233, this IP address of R1. NTP server 209.165.200.233. Configure periodic calendar updates, NTP update calendar - calendar. Enter. Configure Syslog. Enable timestamp service to log the date and time in milliseconds. Service timestamps log date time milliseconds. Enter. Okay, date and time. Date and time. Send syslog messages to 172.30.33. 172.30.33 is this PCC. Login 172.30.33. Set message login severity level to warnings. So use login trap warnings. Ready. Now make some verifications about these configurations. For example, from PCC, verify on R3 the configurations on R3. For example, using PuTTY, you can test the SSH connections 172.30.31. Open yes. The user is admin 01 case sensitive. And the password Cisco 12345. Enter. Okay. The password for the password for the user admin01. The password is admin01 pass. Admin01 pass. Now you are on R3. Very nice. This is the banner, the host name, very well configured. The next. Also, if you want to configure Syslog, you need to install TFTPD PCC on this PC. So TFTPD access here to this side. TFTPD 32 on this side. Download the latest version. Okay. Download this, for example. Transfer this to the virtual machine. And install TFTPD. Install as administrator. Next, install. Completed. Close. Execute this as administrator. Yes. And go to Syslog server. And listen on your IP address 172.30.33. And go to R3. For example, shut down the interface serial 30. Interface serial 30. Shut down. No shutdown. Now you have the message serial 30 change it state to up. So the Syslog server is working very well. And obviously R3 is very well configured for Syslog. Very nice. Continue and configure a zone-based policy firewall. You will configure some policy firewall on R3, only on R3. Create security zone names, inside zone and outside zone. Inside zone is inside, and outside is internet. Go to R3. Exit. Zone security inside case sensitive. Exit zone security internet. Exit. Create and inspect class map. Class map. Type inspect. Inspection type match any. Match any. And use this name inside protocols. Inside underscore protocols. Case sensitive. Enter. Protocols allowed TCP, UDP, ICMP. Match protocol. TCP, UDP, ICMP. Okay, only permit these three protocols. Then exit. Create and inspect policy map. Once class map is created, now create the policy map. Policy-map, inspect, type inspect. Policy map name, inside to internet, inside underscore to underscore internet. Policy map type inspect inside to internet. Enter. Bind the class map to the policy map. Okay, this class map inside protocols. Class type inspect inside underscore protocols. Enter. Matched packets should be inspected. Inspect. Exit. Exit. Create a zone pair. Zone pair. Security. The name into out zone. In to out zone. The source zone is the inside in the destination zone internet. Source inside destination internet. Okay, some pair security into out zone, source inside destination internet. Enter. This will be inside, this will be internet. From inside to internet. Exit. Apply the policy map to the zone pair. Once the zone pair is created, apply the policy map to the zone pair. Zone pair security into out zone. This is the name for the zone pair. So name, the same name of the previous created pair and into outside. Enter. Policy map name inside to internet. The name of the policy map. This name inside to internet. Service dash policy type inspect inside underscore to underscore internet. Service policy type inspect inside to internet. Exit. Assign interfaces to proper security zones. The gigabit inside the serial internet. Gigabit inside serial internet. In my case, I'm using gigabit 10. Remember that 10 and serial 30. Gigabit 10 zone dash member security inside case sensitive. And for serial 30, zone member security internet. Ready. Okay, then verify this. The goal is permit UDP, TCP, and ICMP from the inside zone to the internet, but do not permit connections from internet to the inside zone. How you can verify that? From PCC ping serial 31 on R1 233. Go to PCC ping 209 165 200 233. Success. Now R3 is a firewall and is permitting ICMP from PCC to R1. Now ping from R1 to PCC. The inverse. Exit. Ping the IP address of PCC 3033. This ping will fail because the firewall is very well configured. You are protecting your local area network. Configure an intrusion prevention system. You will configure IPS on R3 using the CLI. All configurations on R3. I was be able to add a flash memory on a GNS3 router, and I was be able to create a directory in that flash memory. I was be able to copy this crypto key file into the running configuration and complete all these steps. But at the end, when copy the signature from PCC to the router, GNS3 go crazy when compile signatures after they are loaded. GNS3 fails when compile signatures. So I was not be able to complete all the steps. If you want to try this, you can add a flash memory on GNS3 router using the following video. And also, you can get more details for IPS configuration on a real lab using the following video. But I will configure all this only on a notepad. Now create a directory IPSDIR case sensitive. On privilege exec mode, create the directory, make directory IPSDIR. Then copy and paste the crypto key file into R3's running configuration. Copy all these in the configuration of R3. But first of all, you need to go to global configuration mode with the configure terminal command, and you will be on global configuration mode. Then copy this. But I will use another notepad to review crypto key, named key, key string. Very good. And add an exit here and another exit here. Then copy this to the router R3. And after that, you will be on global configuration mode again. Create an IPS rule, IPS, use the following name, IPS rule name, iOS IPS. iOS IPS. Now, set the storage location for the IPS signatures, the IPS directory, the IPS directory on flash, IPS config location on flash, the existing IPS directory existing on the flash, the previous created directory, enable IPS SDE event notification, enable HTTP server services, IP HTTP server, enable SDE notification services, security device event exchange, IPS notify SDE, enable IPS Syslog support, IPS notify log, retire all signatures in the all category. Okay. First of all, access to signature category, IPS signature dash category, category all, category all, retire all, retire true, exit, unretire the iOS IPS basic category signatures, IPS signature dash category iOS underscore IPS basic. Okay, this is the category iOS underscore IPS basic. This on retire, so retired false. Exit, then exit again. And you will be at global configuration mode again. Apply the IPS rule to the interface. Serial interface direction in incoming traffic. Serial interface, serial 30 in my case, incoming traffic. Interface serial 30 IPS, the name for the rule iOS IPS, in, then exit, and you will be at global configuration mode again. Now copy the S854 signature from PCC. Okay, use the protocol TFTP. Okay, PCC is a TFTP server, and R3 will be the client, and we'll get the signature from PCC. So you can use this TFTP server on PCC for this process. Exit to privilege exit mode. And copy using the TFTP protocol, TFTP : the IP address of the server, PCC 172.30.33 / the name of the file, iOS S854-CLI.pkg. Compile signatures after they are loaded. So use idconf. And then enter. The signature file on the server PCC will be sent to R3 and then compiled. Before attempting the TFTP copy, the TFTP server software on PCC needs to be running with the directory set to the location of the file. Okay, this is all the configuration for IPS. Now, secure layer 2 switches. Not all security features in this part of the exam will be configured on all switches. However, in production network, all security features will be configured in all switches. In the interest of time, the security features are configured only on S2, except where noted. You will configure security settings on S2, okay, on this device, S2. Assign and encrypt a privileged exit password on switch S2. Enable. Remember, you are on global configuration mode. Enable algorithm type script. Okay, use encryption type 9 script. Secret. The secret password will be Cisco 12345. Cisco 12345. Enter. Very nice. Add a user in the local database for administrator access. Only on S2. Username. Admin01 case sensitive. Admin01. Privilege level 15. Encryption type 9 script. Algorithm type script. Password admin01 pass. The secret password admin01 pass. Okay. Username admin01 case sensitive. Privilege 15. Algorithm type script secret admin01 pass. Enter. Very nice. Message of the day banner only on S2. Banner. Message of the day. Unauthorized access is prohibited. Disable HTTP and HTTP secure server. No, IP HTTP server. No, IP HTTP secure server. Configure SSH only on S2. Domain name. IP domain name CCNA security.com. RSA key size. Crypto key generate RSA general keys modulus 1024. Ready. Version 2 for SSH. IP SSH version 2. Okay, this image of switch does not support this command, but this is the correct answer. I will continue. Timeout 90 seconds. IP SSH timeout 90 seconds. Okay. This image does not support this command, but this is the correct answer. Authentication retries 2. Authentication retries -retries 2. Enter. Okay. This image does not support this command, but this is the correct answer. Configure VTY lines to allow SSH access. Only on switch S2, allow only SSH access. Line VTY 0 to 15. Okay, is line. This image does not support this command, but this is the correct answer. When you enter to line configuration mode, use the command transport input SSH. Enter. Also, this image does not support this command, but this is the correct answer. Configure the AAA authentication and authorization settings only on S2. Enable AAA. On global configuration mode, be sure you are on global configuration mode and enable AAA new model. Use local database as default settings. AAA authentication. Login, the default will be the local database. And don't forget authorization settings. Authorization for exec. Default local. Create the VLAN list on switches S1 and S2. Okay, on S1 and S2. Go to S1. Exit global configuration mode. On S1, VLAN 2, 10, and 99. Name new native case sensitive. VLAN 10, name LAN case sensitive, and VLAN 99, name black hole. Then exit to apply changes to database. Okay, go to S2, global configuration mode, VLAN 2, name new native, case sensitive, VLAN 10, name LAN, and VLAN 99, name black hole. Exit to apply changes on the VLAN database. Configure trunk ports. On S1 and S2 interfaces, Fast Ethernet 01 and 02. On S1 and S2 interfaces, in my case, Ethernet 01 and Ethernet 02. First of all, on S1, interface range, Ethernet 01 and 02. Okay, switch port, trunk, and encapsulation.1q, enter. Okay, this command is only necessary in this image IOU L2 image on GLS3. Also is necessary on layer 3 switches like 3560 switches or 3650 switches. And this command is not necessary on layer 2 switches like Cisco 2960 switches. Switch port mode trunk. Okay. This command is necessary in all switches. Native VLAN 2, switch port trunk, native VLAN 2, prevent DTP, switch port, no negotiate. No negotiate. Enter. Don't worry about this message for now. Now configure on S2. Interface range, Ethernet 01 and 02. Okay. Don't worry about this message. Interface range Ethernet 01 and 02. Switch port trunk encapsulation dot 1Q. Switch port mode trunk. Switch port trunk native VLAN 2. Switch port no negotiate. Okay, don't worry about this message, but these are all the commands. The same configuration as S1. Now disable trunking only on S2. Okay, here exit ports Ethernet 18 and 24. Ports Ethernet 18 and 24. 18 connected to PC, 24 connected to ASA. In my case, ports 33 and 31. S2. Interface range, Ethernet 3.1 and Ethernet 3.3. VLAN assignment time. Switch port mode access. Switch port access VLAN 10. Enable PortFast and VPD guard on S2 ports 18 and 24. 18 and 24, the same ports. In my case, 3.1 and 3.3. Okay, 3.1 and 3.3. Spanning tree PortFast. Very nice. Spanning tree BPDU guard enable. Enter. Very good. Configure basic port security. Only on S2. Port 18. Port 18 is connected to PCB. In my case, port 3.1. On S2, exit interface Ethernet 3.1. Maximum limit 1. First, we'll enable port security, switch port-security. Now, maximum limit 1 MAC address, port security maximum 1. Remember the MAC address sticky violation action violation shutdown. Okay, exit and disable unused ports on S2 and assign ports to VLAN 99. Okay, exit again to privilege exit mode. List all the interfaces in show IP interface brief. These are all the physical interfaces, but I have in use 01, 02, 31, and 33. 4 ports in use. Okay, configure terminal interface range, Ethernet 00, 01, 02, and 01 and 02 in use. So Ethernet 03, comma, Ethernet 03, comma, Ethernet 10 to 13, Ethernet 10 to 13, comma, Ethernet 20 to 23, Ethernet 20 to 23, comma, 31 and 33 in use. Three zero, Ethernet 30, 31 in use, Ethernet 32, Ethernet 33 in use. Okay, 00, 03, 10 to 13, 20 to 23, 30, and 32. Enter. Assign to VLAN 99 the black hole. Switch port mode access. Switch port access. VLAN 99 shutdown. Exit. Configure loop guard on switch S2. Loop guard by default. Switch S2. Spanning tree loop guard default. Configure DHCP snooping. IP DHCP snooping. To enable the DHCP snooping, enable DHCP snooping globally is this IP DHCP snooping. Then enable DHCP for VLAN 10, IP DHCP snooping for specific VLAN 10. And DHCP trusted interface is 24. 24 is the trusted interface because ASA will be the DHCP server. But in my case, the DHCP server is the ASA and the trusted port is 33. Interface Ethernet 33. IP DHCP snooping trust. Exit. Okay, if you are on NetLab Plus, note use a maximum limit of 2 when configure basic port security. make some verifications. For example, to start PCA and PCB. First of all, start PCA. Configure and edit connections. Double click on wired connection, IPv4. Remove this, and on manual configuration, add a new one. PCA on this network 192.168.10 and number 10. 192.168.10.10. NAT mask 24. Gateway 192.168.10.1. Save. And start networking. And ping to verify S1 configurations and show VLAN brief. Use the show VLAN brief to verify VLAN 10 does not have an active port. Okay. Show interface strong. Ethernet 01 and 02 very well configured strong imports, but VLAN 10 does not have an active port. So you need to configure Ethernet 1, 2 on VLAN 10. S1, configure terminal interface, Ethernet 1, 2, switch port mode access, switch port access VLAN 10, exit. Go to PCA and start PCB. Then configure the IP address 192.168.10.11. Subnet mask 24. One 192.168.10.11. Subnet mask 24. Default gateway 192.168.10.1. Okay. Okay, and from PCA, ping PCB. From PCA, ping PCB 192.168.10.11. Success, Control C to stop. Ping from PCB to PCA. One 192.168.10.10. Success. ASA, the default gateway, is still not configured, so pings to the default gateway will fail. Configure ASA basic management and firewall settings. The host name. Okay, first of all, start this device. go to privilege mode with the enable command and no password. Enter. Go to global configuration mode with configure terminal. Enter. Set the hostname CCNA S-ASA. Enter hostname CCNA S-ASA. IP domain name ccnasecurity.com. Domain name ccnasecurity.com. Security.com. A privilege exec password Cisco12345. Enable password Cisco12345. User in the local database with administrator console access. User admin01 case sensitive password admin01 pass. Username admin01 password admin01 pass. Enter. Configure gigabit 1, 2. In my case, gigabit 02. The inside interface on ASA. Interface gigabit 02. Name inside. Name interface inside. IP address and subnet mask. 192.168.10.1. Subnet mask 24. Security level 100. No shutdown. Do not forget this. No shutdown. Gigabit 11. In my case, gigabit 01. The outside interface. Gigabit 01. Name outside IP address security level 0. Name outside IP address 209, 165, 200, 226, 255, 255, 255, 248. Security level 0 because it's internet, insecure network, not shut down. Configure AAA to use the local database for SSH user authentication. AAA authentication. SSH for console access, use the local database. Generate RSA key pair to support the SSH connections. RSA key 1024 bits. Crypto key generate RSA modulus 1024. Enter. Yes. Configure ASA to accept SSH connections from hosts on the inside LAN. This is the inside LAN, this network 192.168.10.0.24. So that's why this is the inside network. SSH 192.168.10.0 subnet mask 24 on the inside interface. And timeout 10 minutes. SSH timeout 10. SSH version 2. SSH version 2. Create a default root the default route, use the NAT hop IP address. The NAT hop IP address for ASA is this interface 225. Route, use the outside network, the outside interface, and default static route, use the NAT hop IP address 225. Configure ASDM, access to the ASA, enable HTTPS server services. HTTP server enable. HTTP includes HTTPS. Enable HTTPS on the inside network. The inside network is this, 192.168.10.0. So use the same configuration with like SSH, but use HTTP. That includes HTTPS. And this is the network subnet mask on the inside interface. Create a network object to identify internal addresses for path, port address translation. Dynamically bind interfaces by using the interface address as the mapped IP. Okay. Object network. This is the name inside net for the object. Case sensitive inside dash net. Enter. Create the subnet. Subnet 192.168.10.0, subnet mask 24. And dynamically bind interfaces by using the interface address as the mapped IP. Okay, interfaces inside, outside. NAT from inside interface to outside interface. Dynamic, use the interface IP address for NAT. Enter. And exit. Now, modify the default global policy to allow returning ICMP traffic through the firewall. Okay, the policy map is global policy. Policy dash map is global underscore policy. Enter. The class is inspection default. Class inspection underscore default. Enter. Inspect ICMP traffic. Inspect ICMP. Enter. Exit. Exit. Very good. Make some verifications. Okay, for example, from PCA ping default gateway. This is PCA ping default gateway 192.168.10.1. Success. Control C to stop. From PCB ping default gateway. This is PCB 192.168.10.1. Success. Also from PCA or PCB, access using SSH 192.168.10.1, port 22 for SSH, and use this user admin01 case sensitive and password admin01 pass. Okay, open. Yes, admin01 case sensitive, admin01 pass. Success. Enable, enter. The enabled password is Cisco12345. Enter. Success. The enabled password Cisco12345. Okay, very nice. Exit. And for example, ASA firewall will permit the ping from PCB to 225 on R1. The ping from PCB ping 209.165, 200, 225. Success. Also the ping from PCA to 225. PCA 209.165, 200, 225. Success. Control C to stop. But the firewall will not permit the ping from R1 to PCB because the firewall is blocking that traffic and also is configured with path. From R1, try to ping PCB 192.168.10.11. Ping will fail because ASA is very well configured. Configure ASA for SSL VPN remote access using ASDM. You will configure any connect SSL remote access VPN on ASA using ASDM. You will then use a browser on PCC to connect and download the Cisco AnyConnect Secure Mobility Client software located on the ASA. After the software has downloaded, you will manually install AnyConnect software to PCC and use it to establish a remote SSL VPN connection to the ASA. Now configure SSL VPN settings on ASA using the ASDM from PCB. From PCB, configure ASA using ASDM. Use a browser on PCB to establish an ASDM session to the ASA. After the session is established, use the AnyConnect VPN wizard to configure ASA to allow SSL VPN client connections. Use a browser on PCB and connect to the ASA. Okay, access PCB. This is PCB. Use a browser. I recommend to use iExplore. No Edge. Internet Explorer. Use Internet Explorer. Use HTTPS with this IP address, the default gateway 192.168.10.1. https://192.168.10.1. Enter. More continue to this website. Run ASDM. Update later. Continue. I accept. Run. Username and password. The previous configured username and password, admin01 and admin01 pass. Case sensitive, admin01 and admin01 pass. Enter. Okay. AnyConnect VPN wizard. And go to wizards, VPN wizards, AnyConnect VPN wizard. Next. Connection profile name. Use this name, AnyConnect SSL VPN. AnyConnect SSL VPN. And use the outside interface. Outside interface. Next. VPN protocols SSL only. Disable IPsec only SSL activated. Next. Client images, AnyConnect wing .pkg or equivalent. Okay, add here AnyConnect image. Browse from Flash. Okay, I don't have the file here. Cancel. So you need to upload the file. Okay, browse for local files. But you can go to my blog to download the software in CCNA security. And down here, you can download the IPS signature for IPS, but in this case, download AnyConnect wing PKG here. And download the file. Okay, the downloaded file is a compressed file, so you need to decompress. So the decompressed file should be a .pkg file, 24 megabytes. And transfer that file to the virtual machine. And browse local files. And on any folder that you want, you should have this file, AnyConnect wing 43.pkg, and select this. Select, then upload file. Okay. Okay. Double click here, browse flash to verify that is placed on the flash on the ASA. Okay, very nice. This is the image. Next. Create a username, VPN user, and password VPN user PA55. Username, local database, VPN user, case sensitive, VPN user PA55. Confirm VPN user PA55. And add. Now, this is the new user for the VPN client. This is the previous administrator. Next. Okay, now create the IP address pool name, VPN pool. Okay, sensitive on AAA, local. Okay, authentication, AAA, local database. Very nice. Next. Then create the IP address pool name, VPN pool, case sensitive, IPv4 address pool, new, the name, this name, VPN pool, VPN dash pool. Starting IP address 192.168.10.2 and IP address 192.168.10.210. Those IP address belongs to this network, the remote network. The remote network for PCA and the local area network for ASA. One 192.168.10.102 2 of 1 ending IP 192.168.10.210. Subnet mask is 24. Okay. Next. DNS server 1020.30.40. 1020.30.40. Knowing server, use this IP domain name previously configured. Next. Next. Okay, this was the domain name. Exempt VPN traffic from NAT enable. Exempt VPN traffic from network address translations. Activate this. And exempt from the inside interface. Inside interface on IPv4. On IPv4. The inside interface. Next. Okay, any Connect client program can be installed to a client device by one of the following two methods. Web launch. On accessing the ASA using a web browser, the AnyConnect client package will be automatically installed. And the second method is pre-deployment, manually install the AnyConnect client package. I will use the most difficult, the first method. Next. Verify, configurations, finish. This is the profile name here. Only SSL and all the configurations. Now, establish an SSL VPN connection to the ASA from BCC. First of all, from BCC ping 226, the outside interface on ASA. BCC is this. Ping 209, 165, 200, 226. To 26. Enter. Okay, success. So you are able to connect the ASA. To establish an SSL VPN connection to a ASA, you will need to use a browser on PCC to download the Cisco AnyConnect Secure Mobility Client software from the ASA. After the software is downloaded, you will install the AnyConnect software to PCC, then establish an SSL VPN connection to the ASA. Use a browser on PCC, connect to the ASA, download the Cisco AnyConnect Security Mobility Client software to the PCC. HTTPS on web browser and use the 226 interface, the outside interface on the ASA. I recommend to use iExplore, no Edge, https://209.165.200.226, enter. Continue to this website and use the VPN user and VPN user PA55, VPN user password, VPN user PA55, login failed. Try again. VPN user PA55, enter. Login failed. Okay, then troubleshoot this. You only need to go PCB to configure ASA, PCB to configure ASA, and go to device management, users AAA, user accounts, and verify the VPN user here. Select this and edit, and change user password. And change a more easy password or the same password. I will use the same password. VPN user PA55. Again, VPN user PA55. Okay, then apply. Ready. And from PCC again, refresh this. To 165.200.226 HTTPS, enter. VPN user PA55, enter. Success. And you can click here to install or download. Okay, continuing in 14 seconds. Wait a moment. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And continue. Okay. Click to install. Yes. Hello. Connect anyway. If software does not start properly, click here. Okay, and close this again. Just for example, Edge HTTPS ://209.165.200.226. Continue with the web page. The username VPN user, password VPN user PA55. Enter. Click here any connect VPN, and now it's downloading. Wait for the 100%. Open folder. This is the installer. Install this as administrator. Run anyway. Yes. Welcome. Next. I have already installed this software, so you can use repair, in your case, install. Finish. Close. Execute the program. Any connect to 165.200.226. Connect and verify that block connections to untrusted servers are unselected here and connect. Connect anyway. Password VPN user PA55. Okay. Connected. Very nice. Verify here the IP address 192.168.10.2.1. The fields in the IP address pool. And the server is this 209.165.200.226. This is the server. Go to command prompt and ipconfig. You have an Ethernet adapter 172.30.33 that is this IP address of PCC, but you established a SSL VPN tunnel to connect this LAN. So that's why you will have another interface, the AnyConnect interface, with the IP address 192.168.10.2.1 and belongs to this network. So virtually PCC is placed here on LAN of ASA 192.168.10.0 network. And you will be able to ping, PCC will be able to ping PCA and PCB because it's virtually placed in the same local area network. And verify that. Ping 192.168.10.10, success, and 10.11, success. verify that an SSL VPN session has been established to the ASA using ASDN from PCB. How to verify that? Access PCB, and PCB is connected to the ASA. Go to monitoring, go to any connected clients, and you have this connection: VPN user, the username VPN user, the IPv4 address 10.2.1. Very nice. Thank you very much.